Now this is a college class, so we're not finding the mean, median, mode, but we also have to figure out what the properties of each of these are as well, okay? And what I had you do is I had these little Post-it notes that said a property of the mean, the median, or the mode. And I told you to get in groups and put where the property most likely goes, okay? So I think you guys did a pretty good job here. But I do want to say I disagreed with one thing here. The rest of them look correct to me. The one thing I disagreed is under mode, I think one of the groups said cannot be used for any qualitative data. Okay. Can someone remind me what qualitative data is? Is it words or numbers? Words, right? Can you find the mode of a bunch of words? Yeah, right. It'd just be the word that happened the most frequently, right? You can actually find the median for some qualitative data. We talked about it on Wednesday. We said it can be used for some qualitative data as long as it can be put in order. So that's why we said it could be used for ordinal data, which I guess leaves one last place for this one to go under. The mean is something that can't be used for any qualitative data. Does anyone know why? Jordan? Yeah, right. You can't just like add up a bunch of words and divide by how many. I don't know how you do it, but if someone could, they should definitely show me, right? If I had a bunch of words, can't take the average of it, right? So under quality or under the mean, I'm gonna write this. I meant to use green here. No, I want to keep it consistent. I'm gonna write cannot be used for any qualitative data. Okay, and that's true for anything when we're finding the mean. Let's finish up the mean here. Underneath mean, we have the mean is most affected by extreme values like high or low in the data set. And I know that's a lot of words, so let me try to explain this a little bit better. Okay, let's say I wanted to find the mean of these three numbers, 1, 2, and 3, right? Well, I can add them up and divide by 3. That's how you'd find the mean, right? Let me ask you another question, okay? What if I, instead of writing 3, I wrote this, 3,000. Would that affect the mean? Yeah, right? Adding 3,000 to 1, 2, and 3 would really offset the mean. The mean would completely change if I replace 3 with 3,000, okay? And because of this, the mean is, well, it's the most affected by extreme values. And I'm gonna write like maybe something's too high or too low in the data set. Okay, now there's actually another word that we can use for this. So instead of saying it's most affected by extreme values, we say that the mean is this. Okay, so instead of writing this big thing, we say that the mean is not resistant. Okay, so the mean is not resistant to change. Okay, so it changes if you change things up. Okay. Any questions on these 3 properties of the mean? Mm-hmm. Oh, okay, before we move on to the median, I want to throw some notation at you that we'll use throughout the rest of the semester, but you won't see for a little while, okay? If we're talking about the mean of a population, we're going to be using this symbol here. It's the Greek letter for M. It's called mu, okay? It looks like a U with a little tail on it. We say mu, okay, and for the Greek letter of M. Okay? Now, if we want to talk about the mean of a sample, we do this. We write an X with a bar on top. So population mean, Greek letter mu, sample mean, X bar. All right. We won't be looking at that for a while, so just to keep in mind. Let's go down to the median. Under median, I have one more thing. And it says that the median is not affected much by extreme values in a data set. So it's kind of the opposite of the mean, okay? If I had, let me give you a set of numbers. 1, 2, 3, 4, 5, 6, 7. If I had this set of numbers, I could find the median. It's literally just 4, right? Now I could change 7 to 50 billion. And it would still have 4 as the median, right? So even though the mean would change a lot, if I change that last number to a billion or a trillion, the middle number is still going to be the same, okay? So the median is not affected, or at least not affected much, by extreme values, like high values or low values in the data. Okay. And if the opposite of that said that the mean was not resistant, well, this means that the mean is resistant. Okay, so this idea of resistance means if I change the highest number to 50 billion, the median would still be the same. It's resistant to change. Okay. Any questions on median? All right, let's go to properties of mode. Under mode, we have the mode may not be a score anywhere near the center of a set. Who agrees with that? All right, I kind of agree with this, and let me explain why. Okay. For example, if I have a bunch of numbers, 1, 2, 3, 4, 5, 6, 7, 8, okay, and the center is around 5, right? But then I throw some big numbers like 20 and 20, 20, right? Now the center of the set is around, I don't know, 4 or 5, right? But the mode, or the thing that happens the most, is 20, which is a lot bigger than the center, okay? So because of this, the mode may not be a score anywhere near the center. Okay, and that's kind of unique to the mode. Okay, usually the mean and the median are very close to the center of the data set. The median is literally the center. The mode doesn't have to be. Next under mode, let's see. Under mode, I have the mode is the only measure that can be used on all qualitative data. So qualitative can be represented using words. Everyone agree that the mean can be used for any qualitative data? Yeah, right? We can always find the most number of words. If you gave me a book, I could find the most number or the word that happens the most number of times, right? So I'm going to write that down here. Okay, the mode is the only measure that can be used on all qualitative data. Okay, so anything with words, you can find the mode. The last one under mode, which I think is kind of fun, we said easiest to determine. Anyone agree or disagree with this one? Yeah, the mode is easy, right? You just find what happens the most, and oh, that's the mode for you. So the mode is easiest to find. Okay. Any questions on the properties of the different measures of center? All right. There's one last thing I want to mention about like describing the mean, median, and mode. We'll talk about this way later in the semester, but we talked about how histograms can have different shapes. We have symmetric graphs where if you drew a line in the middle, it would be the same on each side. We have skewed to the left and skewed to the right, which just means there's a tail either to the left or to the right. The only thing I want to harp on today is if you see a symmetric graph, the mean and the median are always in the center, okay? So we'll talk about graphs that look like this, that are very symmetric, almost bell-shaped. The mean and the median are always smack dab in the center of that graph. All right. Oh, let's keep going. if you take a look at the back page, I'm going to put your mean, median, and mode skills to the test. I have 5 different questions for you. Okay. I want you to either work together or work by yourselves. Try taking a look at these 5 questions. I'll be around to help, and we'll come back in a little bit. Number 1 asked you to find the mean of these exam scores. Kevin, do you want to take us through how you did this one? Mhm. Awesome. Perfect. One thing that I wanted to add on this one is, since this is talking about a population, what symbol am I going to use here? Is it the Greek letter or is it X bar? The Greek letter, right? So if I were to like talk about this, I would use the Greek letter mu to describe 81.2. Okay. Number 2, this one asked me to find the median of the exam scores. Who wrote this one up? All right, Jordan, do you want to take us through how you got this one? Mm-hmm. Yeah. Perfect. So the middle number is the median. Moving on to number 3. Was that Alyssa? Do you want to take us through how you got this one? Perfect, right? So you just take these, add them up, and divide by 2, and you should have gotten 17. All right. Moving on to number 4. This one asked me to find the mode. Mateus, do you want to take us through this one? Yeah, right. One definitely happens the most here. Number 5, this was the mode, but instead of quantitative data, which deals with numbers, we deal with qualitative data. Who put up this one? Was that Maya? Yeah. Maya, okay. Do you want to take us through this one?
Yeah, this counted how many, or which one occurred the most out of all the type of cars, and then it's Toyota.
Perfect. So Toyota happened the most. Any questions on finding the mean? Oh, yeah. Oh, do you want me to zoom in on this one? Oh, go up to the third one. Oh, yeah. So the third one is the median, which is the middle one, right? Gosh, Alyssa did a good job of writing these in order, right? So usually when you find the median, you cross off pairs, right? So cross off the edges, but there's no one number, there's actually 2 numbers in the middle, right? Whenever you have 2 numbers in the middle, you're gonna wanna find the average of the 2 numbers. So the way Alyssa got 17 was taking 15, oh gosh, plus 19 divided by 2. And that's how she got 17. It's a good question. Any other questions on mean, median, or mode? All right. Now, I think these are words that we've at least heard before, and we've probably seen or at least tried to calculate these before. I'm going to give you a different question that you might have not seen before. Okay. Let's say instead of a list of numbers, we just have, well, a little chart that tells us how many times each of these numbers happens. And I wanted to find the mean. Does anyone think I could actually find the mean here? Who thinks this is possible? All right, who thinks it's impossible? All right, I'm gonna give it to you. It's actually impossible. You cannot find the mean if you're just given a chart. And the reason why is because when you're trying to find the mean, you have to have the actual numbers to add up and divide by how many, right? If I don't know the actual numbers, I literally can't calculate what the mean is. Now, you can approximate the mean given a chart, and I'm going to show you what mathematicians have done in order to figure out what's the best way to find what the mean might be given a chart like this. Okay, so I'm going to give you a situation here. Okay, we have 5 numbers in between 0 and 4, 3 numbers between 5 and 9, and 4 numbers in between 10 and 14. Okay, I'm going to give you what the actual data values are, but let's just pretend that we don't know what they are. Okay, so these are the actual data values, actual values. We need 5 between 0 and 4, so we'll have 0, 0, 1, 3, 4. So these are our 5 numbers between 0 and 4. We have 5, 6, and 8 representing those three numbers between 5 and 9. And then we have 10, 11, 13, and 14. And these are our four numbers between 10 and 14. Okay, so these are the actual data values. Let's just pretend we don't know these. We only know what the chart says, but these are the actual values. Okay. This is what mathematicians do to approximate what the mean is. Since we don't know these actual values in green, we're going to make up approximate values. Okay, so these are our guess. Oh God, guesses. Okay. And the way we're going to guess is within each category, instead of guessing like 0, 1, 2, 3, I'm just going to pretend that all of the numbers are the midpoints of that class. Okay. So for example, the midpoint between 0 and 4 is 2.5, right? So 2.5 is the midpoint. 2.5 is that midpoint. 2.5, 2.5, 2.5. So instead of writing 0, 1, 2, 3, and 4, I'm just going to say that those numbers are approximately 2.5. Okay. Instead of 5, 6, and 8, these numbers are the midpoints of the next category. So 7.5, right? 7.5. 7.5. Okay. And instead of the last category, well, I think it's 12.5, right? 12.5, 12.5, and 12.5. So since we don't know the actual values, we can guess what the values are by just taking the midpoints of each of the classes. And depending on if the number is in the first, second, or third class, we're going to approximate it with 2.5, 7.5, or 12.5. Okay. Now, once we have our guesses, we have a data set that we can find the mean of. So we can add them together, right? And we can divide by how many, which is 12. Okay, so this is how mathematicians go about doing the mean, or at least approximating the mean, of any sort of data set where we don't know the actual numbers. Okay. Now, it's kind of weird to do this, especially if we have a large data set. So let's shorten this up a little bit. What's another way to say 2.5 plus 2.5 plus 2.5 plus 2.5 plus 2.5? Times 5, right? So instead of writing 2.5 5 times and adding them up, I'm just going to do this. 5 times 2.5. Okay. And instead of saying 7.5 plus 7.5 plus 7.5, I'm going to write 3 times 7.5. And instead of writing 12.5 plus 12.5 plus 12.5 plus 12.5, I'm going to write 4 times 12.5. Okay, so I'm just shortening what I just did. Okay, and if we take a look at this shortened version of what I wrote up there, okay, what we're doing is we're taking the frequency, right? Because we have 5, we have 3, we have 4. We're taking the frequencies and we're multiplying them. We're multiplying them by the midpoints. Okay, so we're doing frequency times midpoint plus frequency times midpoint plus frequency times midpoint. Okay, we divide by the total. Okay. So the whole idea behind this approximation of the mean is you do the frequency times midpoint for every single class, you add them up, and then you divide by how many you have. Okay. There's a couple ways you can go about doing this with a problem. You can either memorize this system that I wrote up here. You can also memorize these steps that I wrote up, or you can do a chart, which we'll talk about in the next page. Okay, so steps. Compute the midpoints. You need the midpoints to approximate the mean because, well, we work with the midpoints. Step 2, multiply the midpoint times the frequency. That's what we did up here. Midpoint times frequency. Add everything that you get when you multiply the midpoints times the frequencies. And then after you add them up, divide by how many. So you can either memorize these steps or you can memorize this chart that I made up. Okay. So let's take a look at this example. We have all these numbers of text messages being sent 0 to 49, 50 to 99, things like that. Let's say I don't know how to find the mean, but I want to approximate the mean. This is how I go about doing this, okay? What I'm gonna do is I'm gonna write the chart on the left, and then I'm gonna take each steps as like a column in my chart. Remember, step 1 told me to find the midpoint of each class. So in this next column, I'm just going to find the midpoints. So can someone remind me how to find the midpoint of the first class? You did it on your quiz. Mateus. Perfect, right? So when you find the midpoints, you take one lower class limit, like 0, you add on the next lower class limit, 50, and you just take the average of them. So you divide by 2. Okay, so if you do this, we get 25. Okay, now we can do the same thing with the next category. So lower class limit 50 plus next lower class limit 100, divide by 2, that gives me 75. Okay, and you just continue doing that. You do lower class limit plus lower class limit over 2. I'm not going to do all of them, but we get 125, 175, 225. Okay, and then when we get to the last one, I do have 250 as my lower class limit, but I don't have another lower class limit to add to it. Does anyone remember how to get that next number? Yeah. Good, right? So you can either like find the class width and like add it, or you can like pretend what the next one would be, which is exactly what you said. If there were to be another class, like if we were to make it, well, the class width here is 50, right? So you would just add on another 50 to 250. The next class would start at 300 and probably go to 349, right? Okay, so you kind of just make up a next class. That becomes your next lower class limit. And we're doing 250 plus 300 divided by 2. Okay. Well, when we do that, we get 275. Okay. So step 1 was just calculating the midpoints of every single category. Step 2, we take the midpoints and multiply them by the frequencies. So if I were to do the first step here, or the first row here, what two things would I multiply together? I think I heard it. 25 and 10, perfect. Because 25 is the midpoint, 10 is the frequency. So if I multiply those together, we get 250. Okay, so step 2 says take the midpoint, multiply by the frequency. It just makes sense to write it next to the in another column, right? You can do the same thing, midpoint 75 times frequency, which is 5, and get 375. And just do the same thing for every single row. These numbers are big, so I'm just going to tell you what they are. 1625, 1925, 1575, and 1100. Okay. Any questions so far? All right, moving on to step 3. Step 3 says, after you do all of this calculating, you need to find the sum of all the midpoints times frequencies. So I'm just going to go down this column. I'm going to do 250 plus 375 plus 1625 all the way down to 1100. I'm going to add them all up together and you should get 6850. Okay, so when you add them all together, our sum is 6,850. Okay, so we did the third step, which is finding the sum. We did all the adding up. Step 4 is just the final step in approximating what the mean is. So we take our sum, 6,850, and we divide by how many data points there actually are. How do I find how many data points there are? The question doesn't tell us. Elizabeth? Yeah, so in order to get the total, take all the frequencies, add them together, and the total is 50. Okay, so we divide our sum by the total, which is 50, Okay, and when you divide these together, we get 137. 137 isn't the mean of this data set, but it's a good approximation as to what it would be if we did have the numbers. Okay. Any questions on example 1? All right, I'm going to put you to the test. If you flip your page over, we have example number 2. Now, on the test, you have a computer. I can't actually give you this chart because, well, you have to do it on a computer. So this is similar to a test question, for example. I'm going to give you this thing. You either can memorize the steps and do each of the steps, or you can memorize how to make the chart and do that along with calculating the mean. So try doing this, pretend it's like the exam, and do whatever process feels best for you. If you're still working, don't worry about it. I didn't give too much time for this. Since we all have different ways of getting our answer, I'm just going to go through how I would do it and how most people in this room did it. So if you see this chart, you can either like remember the way that we found the formula in the first place. You can remember the steps. I like doing the chart. Okay, so what I do is I just copy down this chart and I'm just going to write the midpoint next to it. So my next column would be the midpoint, right? Okay, so I'm just continuing on what this chart looks like. Okay, what calculation would I do to find the midpoint of the first class? What would I add up top? Good, 0 plus 5, and I divide by 2, because that's what we always divide for the midpoint. So our midpoint ends up being 2.5. I think that's the biggest thing that I see when I look at like work throughout class or on tests and things. I think the thing that messes people up the most is you'll look at the midpoint or the class and it looks like the midpoint should be 2. The midpoint's actually 2.5 in this example. So doing the actual calculation might be a good practice to have. The next midpoint should be 7.5 and the next one should be 12.5. Okay, so that's the end of step 1. Step 2 says take the midpoints and multiply by the frequencies, right? What 2 numbers did you multiply for the first class? 2.5 times 5, right? Take the midpoint times the frequency. We get 12.5. The next one should be 22.5 and 50. Okay. What does step 3 tell me to do? What's my next step? Yeah, you find the sum, right? So you're just going to take all the numbers in the column you just filled out. You're going to find the total, which is 85, if you just add up those 3 numbers. Okay. Next, step 4 says the mean, or the approximate mean, is, well, you take the total and you divide by, well, how do I find the number that I divide by? Add up the frequencies, good. So the total number of things that there are, so total number of data points is 5 plus 3 plus 4, which is 12. So I'm going to divide 85 by 12. And it doesn't really matter to me how many decimal places you get. I usually stick with like 3 when I do an example, but 1 or 2 is fine as well. So 7.083 should be your mean.